Ready to make a real impact every day? Join the Active Day Home Care team and help clients maintain their independence in the comfort of their own homes. Make a difference in someone's life as you provide essential daily assistance and protect their health and happiness. Earn up to $20 an hour and enjoy additional perks like optional daily pay, 401k, paid time off, ongoing educational training, and more. Join a team that values care, compassion, and your professional growth. Visit activeday.com to apply.
Hello, everyone, and welcome to Talk Nerdy. Today is Monday, June 23rd, 2025, and I'm the host of the show, Dr. Cara Santamaria. And as always, before we dive into this week's episode, I want to thank those of you who make Talk Nerdy possible. Remember, Talk Nerdy is and will always be 100% free to download, and the way we keep it going is by relying on support of individuals just like you. We didn't lose our government sponsorship. We never had it, but I'm still going to pull out the NPR PBS hard sell. You can visit patreon.com/talknerdy to learn how you can pledge your support on an episodic basis. The top patrons this week, top patrons every week, get a shout out on the show, and they include Anu Bhadavaj, Daniel Lang, David J.E. Smith, Joseph Lamore, Mary Neva, Brian Holden, David Compton, Gabrielle F. Jaramillo, Joe Wilkinson, Pasquale Gelati, and Ulrika Hagman. Thank you all so much. So let's get into it. This week, I had the opportunity to chat with Dr. Erika Hamden. She's a professor of astrophysics at the University of Arizona and director of the University of Arizona Space Institute. And she was also recently appointed as a member of the State of Arizona Space Commission. She has a new book out. It's called Weird Universe: Everything We Don't Know About Space and Why It's Important. So without any further ado, here she is, Dr. Erika Hamden. Well, Erika, thank you for joining me today.
Thank you so much for having me.
Of course. So we are going to be talking about your new book, Weird Universe: Everything We Don't Know About Space and Why It's Important. But we're also going to talk about, part of this is talking about your work. But before we dive into what you chose to include in the book, let's talk a bit more about you and your work. So you are an astrophysics professor. You're also the director of the University of Arizona Space Institute, which I'm guessing is it's specific to space. So it's not like astrophysics probably covers a lot more than that. What is the Space Institute and how does it differ from just the Department of Astrophysics?
So here at the U of A, we have a bunch of different departments that kind of do different aspects of space science. So like astrophysics, we're concerned with things that are beyond the solar system, which is actually kind of an arbitrary distinction. But if you're observing stuff within our own solar system, that falls under like planetary science. And so here at the U of A, we have a lunar and planetary lab department that does planetary science. And then also, if you study just our sun, then that's heliophysics, which is separate than if you study every other star, which is stellar astrophysics. So the Space Institute kind of encompasses all of these different parts of studying the universe, depending on like if you're looking out into deep space, if you're looking at our solar system, if you're looking at the sun, and actually if you're looking at Earth, but from space, that's like also a branch of space sciences. So the Space Institute kind of acts as like this bridge in between all these different departments to try and coordinate and promote PIs here, faculty here that have ideas for space missions or want to build an instrument for something. So the Space Institute has been really fun for me as director because I get to learn about so much science beyond just my own branch of astrophysics, because all of space is amazing.
Yeah. And so does that mean then that there's also a distinction between what we might consider like experimental versus theoretical physics? So like when we talk about like theoretical cosmology, is that not under the purview of the Space Institute?
So it's definitely less under the purview. Like the Space Institute, we're focused on like helping people at the U of A get big missions funded and providing like infrastructure and support for putting big proposals into like NASA. So we're really on the experimental side. And then once those proposals come in, we have like facilities to do mission integration, like environmental testing, mission operations. Like we're trying to kind of span like a large part of the life cycle of these like really exciting and interesting hardware focused missions that go into space.
I love that. So then the theoretical people get to be in their labs doing math, and then they get to look at your data and
Which they
implement
love.
that into yeah, exactly.
Yes. Yeah, and
Very
the
cool.
theoretical people are super important actually in kind of the mission like life cycle, because the most compelling kind of proposal that you could write for a mission is to say, oh, we have this theory, it predicts either A thing will happen or B thing will happen, and we will put this telescope up, make these observations, and be able to distinguish what is actually happening and like prove or disprove the theory. So the theorists are like actually like the root, the kind of beginning of any good project. You need like that theoretical basis.
I love that. So my academic background, I came from like philosophy and psychology first, so more kind of at the time what felt like theoretical sciences, and then I got really into biology and I did a lot of work in neuroscience, and then I kind of came back into psychology but from a practical perspective and did clinical psychology. But when I was in biology, I definitely recognized that there was this sort of dual force within the biological sciences. There's the really interesting questions that researchers are asking about how things work and why things are the way they are. But then there's also this idea that, well, we can't answer that question until we figure out how to do the thing, and we need the technology, whether we're talking about hardware or like the wetware technology, to be able to do it. And I see that a lot in physics too, that there are like questions that are fundamentally interesting questions, and then there's also like engineering questions that are important.
Yes. Yeah.
Do you find that within, space science as a whole, or within the space science that you're working in, that you have folks that are kind of answering that question from both angles?
Oh yeah. I mean, we have like there's questions that people have had for decades that in a lot of ways they're like great questions. They're like well posed. They like motivate observations. They're like very clean, but the observation itself is just like not possible due to the limits of technology. And so there's definitely been there's a mission that I'm a part of that is launching to space next year. That is this small satellite telescope designed to look at emission around galaxies. And there's like a famous astronomy quote from an astronomer from like the 60s being like, oh, this problem is the most important problem in galaxy evolution. And it's taken 60 years to be able to have a good enough detector, a good enough telescope, a good enough like method to actually have a chance at addressing the question. So I mean it's fun because there's always questions that are like feel like they're impossible, but if you wait enough time then they'll be possible.
Yeah, yeah, that's fascinating. And some people that's their entire sort of obsession, right? Is saying, I need to figure out how to make this thing possible, and I'm gonna work on that component so that then the whole thing can open up for everybody else.
Yeah, there's a certain personality type that's like, how dare you tell me this can't be done?
Yeah. So I'm curious about your work first, and maybe we can take a few steps back and go back to when you were a graduate student, because of course that's where our work starts to kind of come together, and that's where we put in a lot of effort early on. So what was your dissertation on? I know you did your PhD at Columbia. What were you studying there?
So my dissertation and all my degrees are in astronomy and astrophysics, and my dissertation was kind of a hodgepodge of things, but the focus was on, from an astronomical standpoint, it was about looking at the diffuse stuff in our galaxy and nearby galaxies. And by diffuse, I mean things that aren't in like a star or planet or a black hole or like a galaxy. It's like the little atoms of hydrogen kind of floating around, or the little bits of dust like floating around. But these, I think of them as like precursors to the thing. So like I like stars, I like galaxies, but what I actually like is before they become whatever they are, and how that actually happens, like what the process is. So part of my thesis was kind of looking at within our own galaxy, like the diffuse, what we call like the diffuse galactic background, the light that comes from the stuff in between stars in our galaxy, and then I had a technical component that was like technology development, working on these sensors to work in the ultraviolet. And in the ultraviolet, there's a lot of signatures of this diffuse gas. It's mostly emitting light in the ultraviolet. The state of the art of ultraviolet detectors was like not great. And so I spent a bunch of my grad work actually developing detector technology. And then the third component is like, okay, you have an observation you want to do. You have a new detector that can do the observation. So then I had work building various telescopes and instruments to kind of bridge that, where you like put the detector in the telescope and then use it to observe all the stuff that's not yet in a star or a galaxy.
And were these ground-based, or were they things that were launched into space?
So one of the telescopes was ground based, and then one was actually a stratospheric telescope. So it gets launched, but just to the stratosphere,
But
and
not to
it's held,
space, yeah.
but not actually to space.
I
Close,
love it.
very close to, but not quite there. And
Yeah.
that goes on a high altitude balloon.
Okay. It's so, as a non-astronomer sitting here, I'm imagining a lot of the really beautiful images that I've seen from like Hubble or James Webb, where there's like, they're all colorized, and these are all in the visible spectrum, of course. This is just visible light that I'm looking at in these pictures. But I'm imagining all the sort of pretty stuff in between the glowy dots. Like, is
Yes,
that what you're
yes,
talking about? Okay.
yes. Basically, yeah. A lot of what you're imagining is, those Hubble JWST pictures are of regions within our own galaxy, but there's also that same stuff between galaxies. It's just like even harder to measure, and so I'm interested in like that stuff that's within our own galaxy, but also around distant galaxies. That there's this halo of material that is really critical to the life of the galaxy and like how it will make stars and how it will do anything. And that is something that we've only barely begun to understand.
Oh, interesting. And when I think about those images in my head, like this is what keeps getting conjured up when you talk about dust or you talk about these different gases. These are visible light, right? Like when we look at the electromagnetic spectrum, it's like the teeny tiniest sliver is detected in these specific images. But you were working on looking like past that at
Past that,
ultraviolet.
yeah.
And there are other ways to look too. Like you can look at different X-rays, or you can look at like all different aspects of the spectrum, right?
Yes. And like different parts of the spectrum give you different pieces of information about the processes that are happening in the same region. So looking in the visible gives you one view, but then looking in the X-ray tells you about like highly energetic activities that are happening. Looking in the radio tells you about like neutral hydrogen. There's all these different parts. So looking in the UV tells you about the UV is like a signature of birth and death. Like when new stars form, they're super bright in the UV. When they die, they send out emission that has all these interesting signatures in the UV. So that's part of why I like it and wanted to work in it, was that it's like a very rich wavelength range, but it's relatively understudied. Like part of why you don't see images in the ultraviolet is because we don't really have telescopes that have been able to do the same type of flashy pictures that HST or JWST does, but in the ultraviolet. Like we don't have this, you can't make like a mosaic of which includes the UV, because we just like don't have that capability. So that's something in my career that I want us to be able to do. And part of that was making detectors that are better able to take those images.
Well, and it's fascinating to think about because it's not like we don't have UV detection for all sorts of things here on Earth. Like it's not like UV is this enigma to us, but why do you think historically we never built good detectors for observation?
So it is, I think the main reason is that it is relatively useless on the surface of the earth. Like we have some
Oh.
ultraviolet detectors, like, but really like
Mhm.
if you have a UV camera on the ground in the atmosphere, the UV photons get absorbed very easily. There are some that make it to make it through the atmosphere. There actually bees, certain flying insects have uh, photoreceptors that can detect very near UV light. So light that's really close to the visible, but our eyes can't see it, but like bees can see it. And then flowers have these like bullseye patterns actually that is
Oh,
only
yeah, I've seen
visible
those
in the UV.
pictures.
Yeah.
Yeah, where they, like, try and make it look like fluorescent purple or something to, like, show us
Yes.
what a bee can see. Yeah, yeah.
Yeah, like the bee's eye view.
Mhm.
But beyond that, like deeper into the UV, basically, if you had a camera, it wouldn't measure anything because the UV photons are so easily absorbed by the atmosphere, which is good for us. Like UV photons are highly damaging. They get absorbed right in the top layer of your skin. So that's why like they cause skin cancer. And so if we had more UV photons flying around, like it would be really bad for us. But the result is, and the UV photons are not energetic enough, like to be useful the way that X-rays are useful, where X-rays can actually penetrate and give you this like kind of three-dimensional view of something. The UV is energetic enough to be a problem, but not so energetic to be useful in a medical setting, for example.
Right, like, it gives you cancer, but it doesn't show you your bones. Like, we're
Yes,
like, "What
exactly.
do we
It's
do
like
with this?" Yeah.
only the bad parts of it.
Yeah.
and and then in contrast with like the infrared, where you have a lot of commercial or like military applications,
Mm.
and
Oh,
even in
right.
the visible, there's like all these other uh, industries that want to use detectors and technology and like optic solutions. The
Right,
UV
like, I
is
wanna
just
see heat or I wanna see in the dark or something like
right,
that, but UV
exactly.
doesn't help you with that.
The UV is just this like just for basic research. I mean,
Yeah.
maybe we'll figure out useful things for it. But sometimes I talk to people who are like, "Oh, if you put a UV telescope and like look down at the Earth, like, could you see, different materials, or could you see stuff?" I always have to be like, "No, you like literally just see the upper atmosphere, like doing
Yeah.
nothing." um,
Protecting us from
so
skin cancer. Thank you very
yes,
much.
exactly.
Yeah.
You see everything that gets bounced back.
Yeah.
But Yeah, so I think the root of it actually is just that there wasn't an industry-based technology development effort, and so NASA actually did their own kind of technology development effort about 20 years ago, around when I was starting my career, and they were basically like, okay, if nobody else is going to work on this, I guess we have to. So they put a lot of money into detectors and mirror surfaces and gratings, like dispersive elements for a spectrograph, and really just a lot of new capability came out of what in the grand scheme of things was probably just like a few millions of dollars, like not a lot of money, but because the field was so immature, it really like created all this new possibility. And as a result, now there's all these new UV telescopes that people are proposing or that are getting built, that would not have been possible even 10 years ago.
I'm actually, like, just realizing right now, and I'm curious, and it's totally okay, you may not recognize the name, but I have a dear, dear friend who I've had on the show before, named Holly Bender, who's been at NASA for 15 plus years now, here at JPL. She's an optical engineer. She, like, literally leads teams and builds a lot of these, like, detectors and things, both for, like, Earth observation, so probably not a lot of UV there, but also
Yeah.
for CubeSats and then for flying on, like, larger missions, and I would be so surprised if she hadn't, like, designed something for you or with you in the past and you just didn't know it, because I feel like this world is big, but also really small.
Yes, it is. It is super small. Um, yeah, I don't know her name, but it's possible that she's worked on stuff because I work very closely with people at JPL, so I'm sure we know the same
Amazing.
people, and maybe our paths have crossed, and I just don't remember because I'm terrible about
Exactly,
things
that's
like
probably the
that.
it's probably the case that the 2 of you have probably worked on literally the same instrument before and just didn't know it, which is amazing to think about. So what about in those last 20 years? So you kind of mentioned, what you were doing for your dissertation, the questions you were trying to answer. Has that continued throughout your career and just gotten, like, deeper and more refined, or have you started to ask, totally different questions and move in different directions?
So for the most part, it's gotten deeper. It's like the same questions because they're still unanswered, which is very annoying. And because I decided that I love building things. I really like the hardware aspect, and proposing to build a new telescope or even building a telescope that's already been funded. It's like years and years and years of work. Like The mission that I'm the deputy of that I mentioned earlier, it's called Aspera, and it's getting launched next year to kind of answer this like 70-year-old question. We proposed that in 2020. We got funded in 2021, and then in 2025 we're almost done building it, and then in 2026 it'll get launched, and then by 2027 we should have some really cool results. But so that's like and that 7-year life cycle is actually incredibly short. That might be the fastest that I've ever built a
Yeah,
telescope.
that's super short. But I was also I hate to interject and ask this right now because I don't want to take the conversation in this direction, but like, are you guaranteed that it's not going to get nixed?
Um,
Because I feel like there's so many of my friends who work in government agencies are like, we already did the thing. We already got the funding, and now the project is being canned.
so we are sort of lucky in that we've gotten like all the money has come to the U of A to build it. So for the build, like we already have the money in hand and we're very close to the end. We did have some anxiety about if our launch would be funded, if we get a launch opportunity. Um, but so far it seems fine for us. We are very fortunate that the university, the U of A, like is a very strong advocate for our projects and for the missions, and so we've had members of the senior leadership team like going to talk to the members of Congress that represent Arizona and like the senators, and so there's no guarantees of anything. But for this project, at least, we're feeling like we're relatively okay. I mean, I have had other stuff, like I was going to put in a big proposal this summer, and that deadline got pushed back by at least a year. So there's definitely been impacts on things, and it's frustrating.
If for some reason you didn't get your launch window, is this the kind of thing where you can just sit on the technology and launch it later? Or do things
Yeah,
like
we would like
expire? Oh, okay.
we would put it. We'd like pull the batteries out, put it in
Mhm.
a nitrogen box, and then be like, okay, let us know.
Good,
Or
good.
we'd
So it's
go,
not like yeah.
yeah. So, and I mean, for me, my bigger worry is not about funding. It's actually just like you put something on a rocket and hope that the rocket works.
Right, yeah. Yeah, no, I hear that, and that's probably always an anxiety, because there's always that sort of uncertainty, but I can imagine that in an administration that is less less, that's a kind way to put it, administration that doesn't seem to understand or really care much about science, that there may be shortcuts or just, attempts at government efficiency that are less than efficient. Um
Yeah, and we like we think a lot about that, and ways to adjust.
Good, and mitigate
Yeah,
against that. Yeah, and I mean,
yeah,
there's only so much you can do, but we also, I guess we just have to maintain the hope, which is really hard to do, that it's not always gonna be this way.
yeah. And actually, I mean, my view is, and I've been telling members of my group and like people I talk to about this, that for a long time, when I talk to astronomers or scientists, they treat the budgets like the NASA budget, but these like federal agency budgets as a force of nature, like, oh, well, there's a tsunami and like we just have to figure out how to deal with it. And I have been telling people, like, it's not a force of nature, it's not a tsunami, it's people in rooms making decisions, and like you can talk to those people, you can influence those people, like those changes, those things can go one way, they can go another way. And I think that there's been a not even retreat implies that at one time they were more engaged, but there's this feeling of like, oh, well, the science budgets will come to us. And I feel like, no, you have to go get the budget, you have to advocate for it, you have to tell people why this matters, you have to like sell it, like, and that's something that in my social media I'm trying to like sell science and like how it is possible to know something to kind of anyone, an average person, a hostile person even. And I think that's something that now the science community is like waking up a little bit more of, like, oh, you have to make people care, and that's how you get things to happen.
Yeah, and it's always you're right, it's always been like that. These sea changes aren't because of some whim that's beyond our control. I think the hard part is that when there is a sea change like this, sometimes, like you mentioned, those individuals that you have to communicate your science to are more hostile than other times. Sometimes they're very receptive and they fundamentally want, good science and progress. And other times they're like just really denialistic and, just don't get it or they don't want to get it. And that can be really, really frustrating. But you're right. We have always had different administrations. We've always had people with different priorities in charge of these budgets. This may be the most hostile we've had in our lifetime, but we have term limits. Like
Yeah,
we
and
got to hold on to that hope, at least for the time being. We got to hold on to the hope that our democracy will continue forward and that science will continue. But yeah, it's a dark time for a lot of people right now.
yeah, I mean, it's definitely an uncertain time. I think. Did you ever watch Game of Thrones?
I actually didn't, but because I'm not a big fantasy person, but I know of it, so you can make your references.
Okay, so don't watch it. It ends terribly. I'm like still mad
Yes.
about it all these years later. But in the second season, one of the characters who's like very manipulative, like behind the scenes, like baddie, says to another character, "Chaos is a ladder." And like this first character, he starts out being like a nobody, like poor or whatever, and he's like working his way up, and he wants the chaos because that's how he can like climb to more and more power. And I think that is really important to remember when it feels like everything is getting like the game is getting thrown and all the pieces are flying everywhere, that like there is an opportunity for people that can see that. And that makes me like actually very hopeful that like someone who has like swept everything clean, then it's like, okay, now we can do this a better way. We can do this a different way. And like, yes, there's the
Right.
possibility that things turn out badly, but there is also this possibility of like something being better in the end.
Oh, I love that. There's this
Yeah,
intentionality to sow chaos and to use it to the advantage of those kind of at the levers of power, but that also leaves a bunch of open holes to be
yeah,
filled because
and
stuff
like
still has to happen.
yes, and like in the chaos, like who grabs the lever of power? That like all of that is up for debate, and so I think there's a lot of to me this is like uh there's just a lot of possibility if you can like see it.
So let's talk about that possibility a little bit. Like we've been talking about your research interests and your work. How does your work then translate into your new book? Did you, speak from your own experience? Did you speak from the open questions that you're asking? Or does your book take an even broader view and say, okay, I'm going to put my work on the shelf and I'm going to more focus on the types of things that I like teach my students, for example, in the classroom as opposed to in the lab?
Yeah, so actually what's interesting is if you read the book, you don't learn a single thing about what I do. Yeah, like I completely in a lot of my communication I don't really talk about the particulars of my research, and I think that's because I spend so much time thinking about it. It's like always in my head, and then when I like meet people and I'm talking about stuff, I like talk about other things. I like don't talk about my work. And so I wanted the book to be something that um, anybody could read and feel like they have a deeper understanding of both the universe and the process of science without having to bring anything with them. Like
I
they
love
don't
that
need to
because it
have taken a
is.
class. They just are like, oh, I
Yeah.
want to know, and that's the only requirement.
It is really readable. It's not jargon heavy. It's like it uses language that is compelling, but not overly, dense or convoluted. And it's also, I mean, just to be honest, like it's short. Like it's a
Yes,
small book. It's very manageable.
yes. Someone else I was talking to was like, oh, you can put it in your hoodie pocket.
Yeah. Yeah. This is a perfect airplane book because, like, yeah, you can definitely like pocket this and like take it with you and just pull it out anytime you have downtime. You're like on the tram or whatever and you want to squeeze in another chapter.
I had some anxieties like, oh, what if it's too short? But I also felt like, oh, I want it to be approachable. Like I definitely didn't want a massive like door stopper.
No, I mean, I gotta be honest. I'm a scientist. I have a doctorate. I spent a lot of time in school, but I get very overwhelmed when I see like a physics tome. I'm like, I don't know if I can handle that. I don't know if I'll be zoning out or if it's gonna be too complex for me or if I'm gonna be able to wrap my head around it because it can get difficult very quickly. quickly. And that's not to say that difficult is bad, but it's one thing if you are dedicating your life to answering a question. It's another thing if you have a particular hobby or an interest. But if you're just a person who's like, I want to have broad interests and I want to know stuff about the universe, but I'm not going to dedicate like all of my free time to it, you may not want to pick up a
A,
big,
a
thick
brief history of
astrophysics book.
time.
Yeah, exactly. Yeah. I was going to say a Hawking book, but then I was like, oh, he's pretty accessible, but nah. Yeah, I hear you.
Yeah, so
So,
I want, like, I believe that all people, like any person, can learn anything about any topic if they're like given the information in the right way, if they are interested in learning it, and if they like have the time and space to digest stuff. And so I tried to make the book like adhere to that belief.
So I'm curious. I want to ask you kind of a random question, and this is more of a process. I tend to do this. I've noticed this lately on the show that I'm asking a lot of like process questions as opposed to content questions. I guess the reason I do that is because it's like, well, read the book. The content's in the book. I don't want to give away everything in the book, but we
The
will
book's
we
great,
will touch
guys.
on a
Read the
few
book.
things. Yeah, read the book. Damn it. We will touch on some of the weird universe stuff, but a process question that comes up for me, and this may be a tangent we go off, or it may be like a no, that didn't really apply here, and that's fine too. But this past week on the show, I interviewed Carly Ann York about her book, Silly Science, where she talks about these sort of very serious investigations that are often described as unserious by like Congress or by individuals who are trying to like minimize the science or be like, we shouldn't fund this, right? And so she picks these examples that kind of to the naked eye are like, why are you doing this? Like, ostensibly, this is dumb and it's a waste of money. But then, like, look at all the interesting stuff we learned from it, right? But one thing that we talked about is how when she was first pitching or early on when she would write for like Scientific American or these different outlets, people would tell her, your work is too bubbly or your work is too. And she was like, nobody would say that to a man. Like, that's such a, gendered kind of insult. And we
Yes.
talked about how very often when writing science, we live in a culture, we live in a universe, we could say, at least here, well, not at least here in the United States, across the globe, where women speak the language of men, but men don't speak the language of women, right? We're all in the same patriarchy, so women have learned to sort of see through the male gaze, but
Yeah.
men have had the privilege where they don't have to see through the female gaze. So I'm curious, as a scientist who also happens to be a woman, when you write, do you think that somebody reading your book would recognize, or do you think that there are things in how you write that like only a woman could write?
That's a tough question. I feel like um, I write, I don't know.
Yeah,
I like,
right. I love it. Because you
um,
are a woman, right? You're not writing about gendered things per se, but
yeah,
you are a woman who has been in an academic environment that is sometimes kind but often hostile, and
yeah,
you were raised with a certain level of empathy and a certain level of emotional sort of regulation and tolerance and thinking because you were raised as a woman in a patriarchy. And so, you're writing for a general audience. And I can imagine that you're writing in such a way that you're thinking about all of those things and you're thinking about women reading your words. You're not just thinking of the default as being a man.
yeah. I mean, I did like take care to think about certain instances in like the history of astronomy that people the data used relies on work done by like you know a bunch of women in the background, and that was very common like 100 years ago. Like Hubble's measurements of the expansion of the universe and even like the distances to galaxies like rely on work done by a bunch of the Harvard these women who were at Harvard. They were called computers, and they like some of them never got PhDs, although they were doing PhD level work and doing this like really tedious and incredibly attention requiring analysis of like a million photographic plates of the sky and like noticing these patterns because they were looking at millions of stars like over and over again. So there's a few of those instances where I try to bring out people who kind of knew what was up, and because they were women, their contributions were like shoved aside.
Yeah. And very often, not I don't know about then, but especially later at NASA, which was NACA at the time, Black women.
Yes. Yeah.
Which is like, so it's not just about the gender, it's also about the sort of racial discrimination. Like, people that historically were viewed as not capable or competent to do things, and then all of a sudden not all of a sudden, often put in these positions where they have to be capable and competent, but then
Yes.
there's,
Because,
like,
like, of course
excuses
they
made.
are.
Of course they are, yeah, right, and so then it's like, "Oh, well, but that doesn't change the narrative." It doesn't change the narrative to say, "Oh, they are capable and competent." It just says, "Yeah, well, we told them what to do and,
Yeah.
or whatever. We put them in the right
Yeah.
positions."
But yeah, I
Like,
mean, that's
okay.
and that kind of thing has been going on for so long. Like the I did some research for one of the chapters about kind of um, the different cultures and their cosmology, and like how we evolved from much more like myth based ideas of like how the universe works to observation based thoughts. And it was really interesting to read about, like, we here in America, you in astronomy you learn like, oh, the ancient Greeks thought this, and then Copernicus, and then Galileo, and then Newton, and then Einstein. But actually, like, the way that other cultures viewed the setup of the universe was very interesting. Like, for in ancient China, like, they didn't actually care about why so much as like the mechanics of what was happening. So they were much more careful observers from very early on. Or like the medieval Middle East, like the medieval Arab world, they were also extremely careful observers because they needed to know when Ramadan started, when like the moon was in the right phase. And so, like, I discovered that actually Copernicus's work, like, him saying that the sun is the center of the solar system, that actually was based on a ton of work from people in the medieval Arab world, and like people working in what is now like Iran or Baghdad or Syria. And, they like were arguing hundreds of years before that actually, like, a better ordering of the universe would be one centered around the sun.
That's fascinating, and it's so, insulting that we don't think. I mean, even going back farther than that, we wouldn't be able to do any of this if we didn't have, like, their
Yeah.
math.
Um,
It's, like, crazy to think about, like, and we just take that for granted. We're like, "Oh, yeah, that's totally white people." Like, it is not white people. That is not where all
yeah.
of this started.
And so, yeah, I think it's part of what I want to show in the process of doing science is like nobody does it alone. You're always building on the work of the past, and that the important thing is to like have evidence for what you're claiming. Like, there was an ancient Greek astronomer who, like, thousands of years ago was like, the sun is bigger than anything, it should be the center of the universe. And that was his theory, and like he was right. I mean, not about it being the center of the universe, but it's the center of the solar system. And his
I guess
reasoning
the
was pretty
universe if we
good.
knew it then. Yeah.
Yeah, like everything that you can see, he's like, I don't know, it seems like the sun should be the thing. And but he had no, like, there was no observational framework or like evidence to support it. And so things like that just like float along as a theory until somebody finally gets enough information to be like, no, this is why. um and that I like actually really admire that. Like, it takes a huge amount of creativity to be like, I don't know, guys, I think it's this other wacky thing.
Absolutely. Oh, it's super cool. And I love that you touched on some of those things in the book. One of the questions I always ask authors specifically, I'm fascinated by the concept, and whether we're talking about an article in a different like outlet or even a published journal article, where we have a little bit more control, but definitely in trade publications, is like books have titles and cover art, like, they matter, right? Because they make somebody go, "Am I interested in this or am I not?" Or, what is this actually about?" But very often, authors don't pick their own titles. Like, they have a working title, and then the editor's like, "That won't sell. Like, we're gonna do this instead." And so, I'm curious about just even the concept of, like, weird universe. How well does that map to the book itself? And is it the title you always wanted, or was it sort of a compromise?
So it was the title that I had at the very beginning. Like,
Oh, amazing.
when I was writing kind of my book outline and proposal, I came up with, like, I don't know, 10 different titles. And in in even the initial discussion with the editor and like I was like, oh, I've been kicking around this idea like calling it Weird Universe, and that was like always the that so in my like kind of editorial brief, like the first book title idea is number one, Weird Universe, and then a bunch of them are all like the rest of them are bad. Like honestly bad. So for me, I always had a very clear view that that's what it was.
Oh, good. So that really maps to exactly what you were setting out to communicate. So let's talk about that, like how the book was organized and what you sort of mean by weird universe, like why that was the approach.
The idea behind it, and most of the chapters are focused around how humans have looked out at the universe as long as there have been humans and have asked questions about like, what are those dots in the night sky? What is that giant ball of fire in the sky? Like, why do things move the way they do? Like, what does it mean? And basically at every opportunity, we're like, well, obviously we are the center of everything. So anything anything out in space should be exactly like it is here. And like the example that I've been giving, because it to me is just like the wackiest one. Up until like 100 years ago, 90 years ago, people looked at the sun and they were like, well, it must be made of the same stuff as Earth, but it's just on fire for some reason that we don't know yet. And the actual truth is like way better, way more interesting, way weirder, that like, no, the sun is made out of hydrogen, which is way more abundant there and in the universe than it is on Earth. Like, and it's run by fusion, not like combustion or, anything that you might experience on Earth. And so at all these opportunities, we think like, oh, this thing in space must be exactly like the Earth, but it's not. It's weirder. It's more awesome. And over and over again, we've had to learn that lesson of like, no, it's not like Earth. It's different.
Well, and that Earth is kind of weird, right?
Yes. So in fact, actually, Earth is the weirdo.
Right, like, we're the other. That's why, like, we've only found us so far. There's probably more,
Yes.
but, like, not anywhere near us, probably.
Yes.
Too near
And
us.
like,
I guess that's a relative term, near.
yeah. Yes. Oh my God. So a lot of the chapters are trying to introduce concepts in space, but with this view of like, we used to think this one thing, but actually turns out it's probably something else, and probably weirder. And so originally it was structured a little bit like the original draft that I wrote had a different ordering of the chapters, kind of more starting from like close by small things and then getting bigger and weirder. But then I decided like part of my view that anybody can learn anything, like I use the example of general relativity and like the nature of space time, and that it's held out as this like utterly complex, indecipherable, like so complicated, like you have to be a genius in order to understand anything about it. And I hate that because I don't think any of that is true. So I put it as the first chapter to just be like, normally this would be the end chapter in a book that maybe you would never even get to, but like we're doing it right now.
I love that. Like, we've got this, and everything else after that is gonna make a lot of sense because we've got this too. This idea of, like, I don't know, it's almost like an anti-anthropocentric view or maybe a anthropo-not-centric view, which I love because that is one of the hardest, I guess, perspectives to shake, and it's all about reframing, right? Like, as soon as you sort of get out of your own way and recognize that I hate saying it this way, like, we are not special because we are still special, but that Sagan of it all, right? Like, we are a way for the cosmos to know itself, but the cosmos just is. And we're special because we're aware, but that's the only real reason. We are just kind of the way that things would have shaken out with enough, I guess, permutations.
Yeah, I mean, given gravity and certain constants, like maybe we are inevitable.
Which is fascinating because I see it a lot in biology too. Like I see it, this is how my brain works. Like I'm always trying to make parallels between things that maybe aren't very parallel. But I see it a lot in biology too, that like sort of we are it and everything else is other. So that's animal, but we are human. And it's like, humans are animals. Like there's nothing exceptional about us except that we are self-aware. And that like, we can point to like certain types of language, we can point to tool use, we can point to our ability to contemplate our own existence. But in doing so, there's like this fundamental, I guess, need to go, therefore we are normative and everything else is other. But if we can break that, not only I think does it help us understand, astrophysics and understand biology and chemistry, it also helps us understand the origins of hate and the origins of misogyny and patriarchy and white supremacy and all these different things. This idea of there being a special normative and then everything else being other is like deeply dangerous. And it's no different from thinking about space in that way.
Yeah. And like, I actually think as I get older and like learn more, and maybe as we learn more, I am more and more convinced that actually the things that we think make us human are found in a lot of other creatures. I read this book about plants, and like it included a thing about plant consciousness. And I was recently talking with someone here who's studying like what's the origin of consciousness. And like, I feel like the more that we learn, the more we're going to have to conclude that like a lot of things are way more conscious than we think that they are.
Yeah, that our definitions have been more inclusive than exclusive for so long.
Yeah. And like, so now, of course, when I like go out in my backyard in the morning to have breakfast, and I like say hello to my fig tree just in case it's like
I love it.
lightly aware of things.
We're gonna have to start doing that with the AI too. It's so scary.
Oh, God.
Please don't turn on me. I'm your friend, not foe. Um,
I will pull the plug on that machine anytime. Like the AI knows that I'm its foe.
Yeah. Well, and sadly, I shouldn't say sadly, I mean excitedly, but also like carefully, this type of like machine learning, you're already using it in your work and it's going to continue to be an important part of your work, I can imagine, even if we don't recognize it because we're
Yeah,
learning on
and
these huge data sets. You're contributing to
astronomers.
the AI's knowledge.
So the astronomers have used machine learning for a long time. I actually think that I call it machine learning or like large language models because it doesn't know anything. It just is like guessing, and I think I view it as more of a labor issue than a some fundamental like limit or replacement or something. I think that it's more used by people that want to fire all their employees as like a it's like a boogeyman for right now in its current incarnations. I feel like I've said this to people that like if you want, I can drink a bottle of water and give you the wrong answer.
It's so
Like
true. Like, please don't use
that's fine.
ChatGPT for everything that you can just use
um,
regular Google for.
and actually, like to your earlier question, like I am a very process oriented person. Like I think that the point of almost anything is not the output; it's the process to get there. Um, and so for me, in like my like the way that I think, the way that I structure my ideas, like it's about the process. And that part is important for me, and then the product at the end, I'm like, okay, whatever. Here, take this thing that I made. But like the part that is interesting to me is all the work, and not just like, oh, here's this piece of slop.
And sadly, that's the black box when it comes to a lot of machine learning. Like you can't, it's like with a student, you have them write an essay or something or come to a conclusion. It's like, well, show me your work. And they're like, I can't. You're like, well, then I don't trust that this is the answer that we're looking for. I need to see the
Yeah.
work.
And I
Oh,
think
that's
maybe that comes
interesting.
out of all the math classes that I've had. Cause like, yeah, the point isn't the number at the end. The point is like, how did you get there?
Right, because you could turn certain aspects of mathematics on their ear. You hear these stories all the time of these like really creative young mathematicians who are, given a task and then they're supposed to do a proof or something, and it's like, no, but you got the wrong answer, and it's like, no, but your work is right. Maybe we've been thinking about this different. Maybe there is another way. I love that.
Yeah. So like I would be way more interested and curious about a computer program that is able to like make ideas around ways of thinking or different like structures in a process. But I feel so strongly that like the process is the point.
I love that. So I wonder, is there a way, just to be a little creative here from a process perspective, is there a way to map that onto the book that you wrote then? Because if the process is the point and you sat down to, how long did it take you to write this book, by the way?
Um Probably a year.
Okay. Yeah. So over the course of that year, you were probably writing and deleting and scribbling and throwing in the trash and, doing all the things that writers do when they're staring at a blank page. And ultimately, you did land on a structure. You landed on specific things to include, other things that you had to kill, darlings you had to kill, or things that you knew that, weren't going to make sense here. How did that sort of process then lead to the final product? How did you choose the weirdness that you wanted to be in the book?
So I first wanted something like, okay, if this is the only one, then I want to pick the weirdest things, like the weirdest things that aren't like, you could make a whole book about the weirdness of like neutron stars or the dead remnants of stars. But I wanted to cover a lot of topics, but at the same time be like, okay, what's like the greatest hits of weirdness. So that's kind of what I thought about, and then I was also very concerned both that it not be too long or too short, and I wanted people to be able to like read it, understand that one chapter, feel like they could go dig up more stuff, but not have to. And so I spent a lot of time in like a meta state of like thinking about like how would somebody reading this feel about this. I spend a lot of time like I write these huge proposals for NASA, and to me one of the key parts of the proposal process is it doesn't matter what you think you are writing or what you think you are saying. It matters how the reviewer understands it. And if they take away something that is different from what you're trying to get them to take away, like that is your fault. It's not the reviewer's fault. The reviewer is doing the best they can. They're probably in like a middle seat in the back of an airplane on their way to a conference trying to read your thing.
And they don't have
And so
access to your brain
yeah. And
and
so
all
your
your
job,
previous knowledge and
like
context.
if they misinterpret it, that's your fault. And so I spend a lot of
Yeah.
time when I'm writing overall just thinking about like how would someone that is not me read this, and how can I make them feel like comforted and supported? Like I imagine them as like a little baby bird that I have to like cup in my hands.
Let me chew this
um,
food for you before I give it to
yes,
you.
like how
I love it.
like how can I keep you alive long enough that you can then
Yeah.
go and like learn more things on your own?
I love that so much. And so, because that's the other thing, as a reader of this book, and I can put myself squarely in their shoes, I'm not a physicist, right? As a reader of this book, I have no idea what you left out. I only know what you included because I don't have access to all of the information that you have. And so I can look at this and think, ooh, these are the greatest hits, or this is the most important part. Or I can be like, I'm so curious, there must be so much more. I want to keep going. But you are sort of the curator in this situation. And that's kind of feels like a big responsibility.
I think about that also because I teach a class here that's the intro. It's intro astronomy. It's typically for non-science majors. So these people will probably never take another science class. It might be the one and only science class that they take in their entire college careers. And so I feel this intense responsibility to teach them not even any specific fact, but like how does science work, and like and that it is possible to know things, that there is like a reality that we can observe and understand. Because I feel like a lot of modern propaganda and like manipulation isn't about this is wrong, the truth is actually this, although there is some of that. It's more of like this mushiness of like, oh, you can never know what is real. And so that is what I like want people to feel like it is possible to know something and to understand it, and like there are things that are real and we understand them. And so maybe this is a book that like somebody who has no experience in science is going to pick up and read, and so I want them to kind of take that away. And like when I talk to my students at the end of the semester on the last day, I'm like, oh, you're a captive audience now, I'm going to give you advice. And one of the things that I say is that like I hope from the class that they take away, if they ever become like a senator, or a congressperson or someone who's making decisions on a large scale, that they will understand the value of science and support that and like think back on this class.
Oh, I love that. I'm curious then here in the last few minutes that we have, we talked about how you opened the book with this idea of like, let's just dive right into quantum mechanics. Like it's understandable, you guys. Like here are the basics. Like, come on, we can, we may not be able to get into all of the nuance, but like we can walk away from this and have a conversation at dinner with our friends about it. What are some of the kind of greatest hits, as it were, that you did make sure made the cut? Like, what are some of the big topics that you were like, this is weird, I couldn't not include it, I love this stuff?
So I talked about just all the stuff that we don't know. Like I return again and again to the idea that of gravity as by far the most important thing in the universe, but our understanding of it is so limited. And yet it is responsible for everything. Sure, we need the other forces, but it's like gravity. Like if you don't have gravity, then nothing is ever going to happen in a universe.
Right.
And
Everything just keeps flying apart, I guess.
yes, it just is like floating along, doesn't care about anything. And I also wanted to talk a lot about planets. Like there are several chapters that are about our own understanding of the planets in our solar systems and our misunderstandings of them. And then the planets that we've observed out in the galaxy. Like there's a chapter that's called "Every Planet We Reach Is Dead," because we've discovered like close to 6,000 planets, and literally all of them are awful, just awful. Like you go there and you would die instantly, no matter how much
Yeah.
equipment you had. It's just like barren, too close to its sun, like too hot, too big, too terrible. Sulfuric rain, like it's all just the worst. And I think people assume this is maybe an instance again where we're like just too stuck in our own brains, but like here we are on Earth. If Earth exists, there must be many of them. There must be many planets like Earth. We assumed that solar systems would be like our solar system, but none of them are, and none of the planets are like Earth. And we only have found 6,000, so we need to find a lot more. But I think it's really important to highlight, like, for the foreseeable future, this is the one. And I do also have this other chapter. I have this other chapter about how big space is. Like, space is really big, and like people don't have a conception of just like, I think this is why people think aliens have come to Earth, but they have no clue how big space actually is. And that even if we did find that one Earth somewhere else, like unless we understand something more deeply about the nature of space time and how to manipulate it, like we are not going there.
No. Or even if we could, it would be like generations later by
Yes.
the time we got
Yes.
there.
Yeah.
Yeah.
Yeah, like you and I, we're not going there unless there's a breakthrough in our understanding of space time. But I think people think like, oh, there's tons of planets. There must be tons of planets like Earth. And I think I wanted to really highlight how inhospitable every place is.
Yeah, I mean, it's definitely the Star Wars effect. It's quite dangerous. But I think even to further that along, the point that you made about how like this is the one and the only, it's such an important point, especially when we talk about the rhetoric that we hear from like the Musks of the world, like the colonize Mars bullshit. Like if we can't figure out how to successfully live under the ocean, or if we can't figure out how to successfully like manipulate the things we need to manipulate here on the planet to live even in spite of climate change. Like if climate change is wiping us out, in what universe do we have the skills to terraform Mars and make it livable? Like it's just so bizarre to me that people really think we could just go there and like hang out and it'll be totally comfortable. It's like we can't even live here safely because of what we've done to the planet. Until we can figure that out, we do not have the skills to do that times 1,000 on
Yes.
Mars.
And like honestly, anytime anybody talks about terraforming Mars, that is a sign to me that that's somebody that doesn't know anything about anything, and you should feel free to
Right.
ignore the rest of their comments because
Thank you.
Mars doesn't have a magnetic field. So even if you spent a ton of time and energy pumping like gas into its atmosphere, the reason it doesn't have an atmosphere now is because it all floats away, because it gets sputtered away at the top because there's no magnetic field to shield it from the energy of the sun, from cosmic rays. So like you can't terraform Mars. Like it's a physical impossibility. And that actually reminds me of this article I saw from someone, I think it was like DeepMind CEO or something, talking about the capabilities of large language models. And one of the things that they wrote was like, oh, in 5 years we'll be colonizing the galaxy. There is a like that shows me that this person does not understand anything, because like they're like 5 years from now, even if you could travel at the speed of light, you would be 5 light years away. You're not colonizing the galaxy even from this moment. And so that tells me this person is like fundamentally unserious, or they're so high on their own supply that they think that the stuff that we haven't understood about the nature of the universe is because we're not smart enough, not because there are limits actually to the universe. Like the speed of light is not a problem for us to solve, it's a thing.
Right. Yeah, yeah, yeah. It's not something that like our prowess is going to overcome. It's a fundamental limit. And even things that seem more plausible, like, okay, the moon, it's far, but it's not that far. Like we can get there, and sure, there are lava tubes on it, and maybe we could hang out in those. Like, do you want to live that way? Like, I don't want to live in a cave. I want to enjoy the ocean and the sunlight and all the it's like, why is that something that people are like, "Ooh, let's have our sights on that." No, let's fix here so we can keep doing the things that we evolved on this planet. We are perfectly attuned to this planet, not to the moon.
Yeah, there's a lot of other issues of like, okay, humans and low gravity, there's a lot of problems with that. And but
Right.
the
Like, "Do
other
you want
thing,
jelly bones?" "I don't want jelly bones."
yeah, I
Like,
like my
no.
bones as dense as they are. I'm always trying to make them
Yeah.
more dense. But in my social media this year, I have a series that I'm doing that's called in 2025 We're Thinking Critically. And I'm trying to teach people critical thinking. It's been really fun for me, and interesting to think about how do you teach someone critical thinking in a 2-minute Instagram reel. But one of the videos I filmed recently was about like some rhetorical moves that people do, like how you can tell if you're having a conversation with someone that they're really trying to divert you or like trick you or whatever. And one of the this I need to like make a note of this, but something that people do frequently is like you'll propose something like, okay, we need to build high speed rail between cities, and rather than address the issue, someone will say like, no, we should actually do this other thing, which they have no intention of doing, but they want you to argue about the benefits of this like made up thing versus something that could be real and good. And I feel like that's what colonizing space acts as, where it's like, okay, now we're arguing about Mars or colonizing the moon rather than like the initial
Than
discussion.
climate change. Yeah, yeah. So it's like whataboutism wrapped up with a straw man, wrapped up with it's like all the fallacies in one. Like, oh, geez. Ugh. Well, and that's why it is so important, right? That's why your book is so important. The work that you're doing is so important, not just in your lab or in your institution, but in science communication as a whole, because you do dedicate. I mean, I don't know how you have the time, but you do dedicate a lot of time, not just to your academic work, but to public science communication, both across your social media, also, the If Then ambassadorship. I have another dear friend, Crystal Dilworth, who does that as well.
Yeah, those people are awesome.
I love that. You also, I love that you have a private pilot's license. Like I'm reading all, I'm
Oh
like,
yeah.
how do you have time to, well, you have to have interests, right?
Yes. I like to keep busy. I'm like always up to something.
I love that. I also have a dear friend, Katie Mack, who is a physicist who also
Oh
flies
yes, yeah.
planes.
Um, yeah, she's a much more advanced pilot than I am, but I'm always conscious of the clock ticking. Like my biggest, like the one belief that I really hold strongly is like one day we're all going to die, and therefore the time that we have is the most precious thing that we have. And so I like hate time wasters. I like and I hate feeling like I didn't like seize the day and like literally squeeze every drop of fun out of it. So I'm
I
always
love
like
that.
packing everything in.
Well, you're speaking my language as somebody who works in cancer and end of life psychology. Definitely this idea of we need to have mortality salience today, right? We need to be aware that this is the time we have, and how you make use of your time is your own. But if you're not aware of it and you're not always thinking about the fact that, this is right now. I can complain about the fact that my joints hurt, and I can complain about the fact that getting old is hard and it sucks. But right now is the most alive I'm going to be. Everything else is behind me. Everything in front of me is continuing to age. So like take advantage today.
Yeah. And I want to feel like when I look back on my life that like, oh yeah, I did everything. I like I like explored everything. I pushed everything, and yeah.
I love that. And so for those who have yet to explore all of the weirdness of space because either it felt overwhelming or it felt scary or had this sort of concern that many of us have, that like learned helplessness or that stereotype threat, that I'm not smart enough to understand this, or I don't have the background that I need to understand this. Pick up this book. I think it will challenge those preconceptions, and it may spark something in you that that feeds that curiosity so that it can continue. The book is Weird Universe: Everything We Don't Know About Space and Why It's Important, by Dr. Erika Hamden. Erika, gosh, I can't thank you enough. This was a fascinating chat.
I thank you so much for having me. It's been really fun to talk.
Absolutely. And everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.